Bismillahirrahmanirrahim. I am Muhammad Ehsan Chatta, Assistant Professor, Government Degree College, Chavatane. Dear student of the second year chemistry, let us learn about the chapter number 1, article Electron Affinity. Electron Affinity, abbreviated as capital E dot A dot electron affinity. The electron affinity is the energy released or absorbed when an electron added to the gaseous atom to form a negative ion. The electron affinity is the energy released or absorbed when an electron is added to the gaseous atom to form negative ion. For example, fluorine have 9 electrons. If one electron is added to fluorine atom, its electron become 10 and its proton equal to 9, which one electron is extra, so its charge would be fluoride negative, F negative. When electron is added to the fluorine nucleus outermost shell, the minimum amount of energy that is released from fluorine atom, that is known as electron affinity, that is will be negative minus 337 kilojoule per mole. Electron affinity always energy released when first electron is added to the atom, but energy is usually released when electronegative element absorb the first electron, and electron affinity in such class is expressed with negative figure as in case of halogens. When second electron is added to a uni-negative ion, when a second electron is added to a uni-negative ion, the incoming electron is repelled by already present negative charge on gaseous ion. Hence, energy is required to provide to enter the second electron. For example, oxygen, when one electron is added to neutral gaseous oxygen, oxide minus 1 ion will be formed. Its first electron affinity will be energy released minus 141 kilojoule energy released, and when this negative ions, another electron is picked up to add to form the O minus 2 oxide ion. The energy added in this case to overcome the repulsion, this is known as second electron affinity. 780 plus kilojoule energy is required to add the second electron in oxygen atom. So it's also indicate the number of vacancy present in the valence shell of the atom which gain electron. Second, third, and so on higher electron affinity always with positive value. All they are endothermic process. They absorb energy because the first negative ions have negative charge. When the second, third, so on electron is added to overcome this repulsion between the ion and electron, we have to provide the energy. So energy in second electron affinity is always positive and absorbed, and it depends upon the size of the atom, nuclear charge, number of vacancies, number of places available in outermost shell, A relatively smaller atom with one or more vacancy in the outermost shell show larger negative values of the electron affinity. First electron affinity की बात कर रहे हैं. Electron affinity is generally increased as with increasing the atomic number within the period. Electron affinity increases in period and decreases from lighter to heavier element in the group of the periodic tables. As we move vertically from top to bottom, size is increased, electron easily added, pick up by the element, so the second electron affinity always with less negative value, less values due to greater size of the atom, due to presence of more shell number of shell, increasing repulsion between the outermost electron and nucleus. This is known as shielding effect. Similarly, dear student, we have classified our table into metal, non-metal characters. It has been discussed in this chapter in early in periodic table. It divided into the metal, non-metal, and metalloid. Chemically, the element that have tendency to lose electron and form positive ion, that element considered to be metal, and all the element that are metal, they are good conductor of heat and electricity. Similarly, another metallic property, their oxide are generally basic in property. When they are dissolved in water, they form जो है वो alkalis, they form basic solution. For example, sodium oxide Na2O, when placed in water H2O, it is moved toward the sodium hydroxide, 2 mole of sodium hydroxide NaOH, known as caustic soda also. So it is the basic solution, it forms the basic solution. Sodium oxide forms the basic solution. So metal oxide are generally, they are alkaline, they are basic in nature. As it become easy to remove an electron of an atom of bigger size, their character increase from top to bottom in given group of the element. On contrary, it decreases from left to right across the period. So the जो metallic characters they are decreases as we move from the number 1A to word number 7A, and the metallic character जो है वो they are decreases as we move in the period. And at the at the extreme right, there are non-metallic element present. Non-metal is that element that have tendency to have gain electron. Generally, these are the gases normally, and these are the poor conductor of heat and electricity. They form the acidic oxide, and examples of these are such as here example is sulfur trioxide SO3. When dissolved in water H2O, it forms the sulfuric acid H2SO4. So sulfur trioxide act as an acidic oxide because it forms acidic solution in water. Similarly, nitrogen dioxide, when placed in water, nitrogen dioxide turn into HNO3 nitric acid. So the NO2 also, the non-metal oxide, it is in acidic in character. Non-metal character of an element decreases as the atomic size increases. Therefore, in group of the non-metal like halogen, the non-metallic character decreases from top to bottom. Fluorine toward the astatine, the non-metallic character जो है वो they are decreases much. Fluorine is more non-metallic character. It form more acidic oxide than chlorine, then fluorine, then bromine, and last astatine, and so on. The fluorine is the most metallic element of the periodic table. Fluorine is the most non-metallic element of the periodic table, and this trend also can be verified by the group element from the 5th A to 6th A lower element of this element, nitrogen and oxygen family. Lower element of these, they are exist in gaseous state, white just bismuth, which act as an fairly metallic character. Their oxide are basic in nature, so generally down the group metallic character increases. Hence 6A and 7A जो है lower at from top to bottom lower element bismuth, polonium. So these are the bottom member of these families. They are fairly metallic in nature. So hence the metallic character down the group increases. It is verified from the non-metallic group, lower element of non-metallic group 5th A and 6th A. Such as an example of bismuth and polonium is the fairly metallic in nature as alkali metal sodium and potassium. Thank you, student. That is the end of lecture. Take care. See you next time.